Factors. How to make a prime factorization tree. Well, what is it? Well, before we talk about the tree, we need to talk about what the prime factorization is. And that is finding a unique set of primes that multiply to a given composite number. Why? Can help make problems easier, like simplifying fractions. Interesting fact. Penguins spend up to 3 hours preening their feathers a day, which spreads oil to repel water, which can be useful when they're swimming or when it's raining. So let's take a look at the vocabulary and what a prime number is. And that is a whole number that cannot be made by multiplying other whole numbers. So let's take a look at an example on the screen, which is 5. And as you can see, 5 is equal to 1 times 5. So there's only two whole numbers when multiplied give you the result of 5. And so another way of saying that, there's only one factor pair. And 1 and 5 is your factor pair of 5. So let's go ahead and take a look at what a composite number is. And that is a whole number that can be made by multiplying other whole numbers. So if we take a look at the screen, you have, we're going to be looking at 10. So on the left, you have 1 times 10, and on the right, you have 2 times 5. Now, since 10 can be written with as a product of two different numbers, then that is going to be a composite number. So on the left, you have the first factor pair of 1 and 10, and on the right, you have the second factor pair of 2 times 5. Now let's go ahead and take a look at the steps. Step 1, make the branches, divide, or using factor pairs, it's up to you. Step 2, add branches until there's only prime numbers left. So let's go ahead and read the first question. Find the prime factorization of 12. First step, write out 12, and then add the branches. And then we're going to go ahead and divide. So since 12 is even, you can go ahead and pick 2, and 12 divided by 2 is 6. And so since we have those two numbers, now we're going to go ahead and take a look at which ones is prime. And on the right side of the screen, we have the prime numbers listed. So 2 is prime. So we're going to go ahead and circle 2. And now since we know 6 isn't prime, we're going to add more branches to it. And now we realize that 6 is also a composite number. And so we're going to go ahead and divide 6 by 2 again. So we get 2 and 3. If you realize that 2 and 3 is a factor pair of 6, you can also go do it that way as well. And now we're going to go ahead and circle the prime numbers. And 2 and 3 are both prime numbers. So we're done with the prime factorization of 12. Now all we have to do is just write down the prime numbers in order from least to greatest. And so we can write 2 times 2 times 3. And that is your prime factorization of 12. Now you may be wondering what happens if you don't choose 2 and 6. Well, let's see what happens. So we add the branches to 12. So instead of doing dividing by 2, or now we're going to divide by 3. So we get 12 divided by 3 is 4. Or 3 and 4 are a factor pair of 12 because 3 times 4 is 12. We're going to circle the prime numbers, and only 3 is a prime number. So now we're going to add the branches below 4. And then we're going to go ahead and pick 2 times 2. And why did we not do 1 and 4? Because if we do that, then you're not helping your case. You're only going to make your tree longer. Okay, so now we're going to go ahead and circle the prime numbers. And since both are 2, therefore both are prime numbers. And now we're going to go ahead and write the prime factorization of those numbers, which is 2 times 2 times 3. And that is your answer. So let's go ahead and take a look at the second example. Find the prime factorization of 25. So we're going to go ahead and write down 25, add the branches, and we're going to go ahead and realize since 25 is a multiple of 5 because it ends in 5, we're going to pick what numbers is 5, and 25 divided by 5 is 5. So now we're going to go ahead and circle the prime numbers. Both are 5, and we know 5 is a prime number. So we get to circle both of them. Since both are circled, we are done with this question. And we all have to do is just write the prime factorization, which is 5 times 5. And that is your answer. Okay, so we're going to take a look at this last example. Find the prime factorization of 20. So we're going to go ahead and write down 20. Add the branches. So we're going to divide 20 divided by 2, which is 10. And then now we're going to go ahead and circle the prime numbers, which is 2. And then we're going to add the branches below 10, since 10 is not a prime number. Once again, we're going to go ahead and divide by 2. And then now we're going to go ahead and circle the prime numbers. And if you realize, if you look on the right of the screen, 2 and 5 are prime numbers. So we circle both. And since we can't add any more branches, we are done. And now we're just going to go ahead and write the prime factorization of 20, which is 2 times 2 times 5. Now, once again, you may be wondering what happens if you do it a different way. Well, let's see what happens. Write down 20, add the branches. So instead of dividing by 2, we're going to divide by 4, and that gives us 5. So, or you can realize that 4 and 5 are a factor pair of 20, and 4 because 4 times 5 is 20. Now let's go ahead and circle the primes, and there's only one, which is 5. So we're going to add the branches beneath the number 4 and continue. Once again, we don't want to do 1 times 4 because it doesn't help us. And so we're going to go ahead and do 2 times 2. Circle the prime numbers. We know 2 is a prime, so we're going to circle both. And now we can go ahead and write the prime factorization, which is 2 times 2 times 5. And that is your answer. Now let's take a look at the first composite numbers. As before, we've written down the first few prime numbers to help us. Let's take a look at 4. Okay, so if we take a look at the composite number of 4, we have 2 times 2, which are both prime numbers, and the result is 4. Now if we take a look at 6, we have 2 times 3, which gives us 6. Now if we take a look at 8, we have 2 times 2 times 2. And look at 9, which is 3 times 3. And if we take a look at 10, we have 2 times 5. And then the last one we're going to take a look at is 12, which is 2 times 2 times 3. Okay, now it is your turn, so go ahead and pause the video so that you can take your time to answer these questions. And I will show the answers in 3, 2, and 1. Here they are. If you got it correct, well done. If you didn't, there's always tomorrow.